Today we're going to be learning about alcohols. So first I would like to give you a basic overview on what we're going to be covering in this chapter. So the first thing that we're going to be talking about is the different classes of alcohols that we have. So the first one is going to be primary alcohols, in which the central carbon, the one that's attached to the OH, is attached to only one other carbon. So this is going to be a primary alcohol. The next one that you have is a secondary alcohol, in which the carbon that is attached to the OH is going to be directly bonded to two other carbons. So this is going to be called a secondary alcohol. The next one is going to be a tertiary alcohol, in which the carbon that is bonded to the OH is bonded to three other carbons. So this is primary, secondary, and tertiary alcohols. After this, we're going to go over the physical properties, the preparations, the reactions, and biofuels. Under reactions, we're going to be covering some main reactions, which are combustion, reaction with metals, bromination, iodination, chlorination, dehydration, oxidation, and the main iodoform test. So this is a brief summary of what we're going to be covering in this chapter. Now we're going to move on to the physical properties of alcohols, and we're going to be focusing on two main physical properties. So the first one that we're going to be talking about is solubility. So in this case, the solubility is going to decrease as you go down the carbon chain. This is because the number of carbon atoms, as you can see, over here you have 2 and over here you have 3. So the number of carbon atoms generally are going to increase, but the OH is going to stay the same. So as you increase the number of carbon atoms, your molecule is going to become less polar, and eventually, if you have more carbons, it's going to start to repel water. Because of that, the solubility is going to decrease around this chain. Over here, you can see ethanol, which is hydrogen bonded to water, and now I'm going to show a hydrogen bond. So this is going to be covered in the bonding topic, with the videos for which will be uploaded later. So in this case, when you make a hydrogen bond, you make it between the lone pair of an oxygen and another hydrogen atom. So over here you can see hydrogen bonding, which is between ethanol and a water molecule, and this is why lower alcohols are going to be soluble in water, because of hydrogen bonding. Next we move on to the second property, which is boiling point. So the boiling point is generally going to be higher because of hydrogen bonding, since hydrogen bonding is the strongest form of intermolecular forces that we have. And the boiling point is going to change in this order. So as you can see over here, primary alcohols are going to have a higher boiling point compared to tertiary alcohols, and we're going to talk about why. So in this case, as you can see, this is a primary alcohol because this carbon over here is bonded to only one other carbon. In this case also, the carbon that's bonded to the OH is bonded to one other carbon. So this is going to be classified as a primary alcohol. In this case, over here you have a tertiary alcohol. So as you can see, this is a straight chain molecule. So it's going to be easier for these molecules to pack together, and the hydrogen bonding, the intermolecular forces between them are going to be greater compared to a tertiary alcohol over here, in which you have 3 carbons bonded to the central carbon. Over here you can see your molecule is more spherical. So because of this, there's going to be a greater distance between the molecules, and the intermolecular forces that you have are going to be lesser. So the hydrogen bonding is going to decrease in this order. So these were the physical properties of alcohols. Now we're moving on to the preparation of alcohols. So for this you have 5 methods. The first one is going to be fermentation. For fermentation, you need some sort of a sugar source. So in this case, we're going to be using glucose. And the conditions for this reaction is that you're not going to be needing any oxygen, so it's going to be anaerobic. You need yeast, which is going to be the enzyme for this reaction. And you're going to need warmth, which in this case, the temperature is going to be 37 to 40 degrees Celsius. And this is going to give you ethanol and carbon dioxide. So this was the first method, which was fermentation. The second way of preparing is going to be from alkenes by electrophilic addition, from alkyl halides by nucleophilic substitution, from the hydrolysis of esters, and from reduction of aldehydes, ketones, and carboxylic acids. And points 3 and 4 have been covered in detail in their respective chapters. Some of the videos for that have already been uploaded, and some of them might have to be uploaded in a while, so you guys can check those out. Now we're moving on to the reaction. So the first one that we're going to be discussing is combustion. So for this one, your alcohol is going to burn in oxygen to form carbon dioxide and water, as you can see over here. In this case, lower alcohols are going to burn readily, and as your number of carbons increases, it's not going to burn as readily. The second reaction that we have over here is reactions with metals. So in this case, you have this alcohol and it's reacting with sodium over here. So what's going to happen is that this hydrogen is going to be removed, and over here you're going to get an ion called the ethoxide ion. And this is going to be your salt. It's going to have a cation for sodium and an anion from the ethoxide ion. And in this case, you're also going to get half a mole of hydrogen. So this was an example of ethanol, and now we're going to look at the general equation. So in this case, you have ROH. The R here represents the carbon chain. This is going to react with sodium to form this salt and hydrogen. And one very important thing to note is that alcohols do not react with alkalis, they only react with metals. The next reaction that we're going to be discussing is bromination of alcohols. And bromination is a type of nucleophilic substitution. In this case, the two reagents that you have are going to be your alcohol and HBr. However, HBr is a toxic gas, so you prepare it in situ. This means that this is going to be prepared within the reaction. So for this, what you're going to do is you're going to react sulfuric acid with potassium bromide, and you're going to get HBr as your product. So in this case, you don't directly add HBr because it's going to be very difficult to add it because it's toxic. You prepare it within the reaction, which is called in situ. So in this case, what's going to happen over here is that the OH over here is a very poor leaving group. So in this case, what's going to happen is that it's going to get protated. And because of that, you have this intermediate over here, which is very reactive and very unstable. So this bromine from HBr is your nucleophile. And it's going to be attracted to this partially positive carbon over here. You make an arrow from the lone pair towards the carbon. And because of that, this bond is going to break off, the one between the carbon and the oxygen. Is going to break heterolytically, and you are going to get an alkyl halide and water. So this was bromination of alcohols. Now we're going to be moving on to the chlorination of alcohols, and in this case you have three reagents. So the first one is going to be PCl3. In this case, you are going to get an alkyl halide, and you're also going to get phosphorus acid. The next reaction that you have is with PCl5. So in this case, you are also going to get the same alkyl halide. Then you're going to get phosphorus trichloride oxide, and you're also going to get white fumes of HCl. And you can use this reaction as a test because you're going to see an observation, which is white fumes. The third and the most important reaction that you have over here is with thionyl chloride. So in this case, you're going to get the same alkyl halide, and you're also going to get sulfur dioxide and HCl. So in this case, these gases are going to escape, and you're not going to need to purify the alkyl halide. You can easily obtain it. So this is why this reaction is the most important out of all of them. So in this case, if you want to test for sulfur dioxide, you can use potassium dichromate. And the observation for this, it's going to go from orange to green. The next reaction that we're going to be talking about is iodination of alcohols. So the reagent that we use for this is going to be Pi3. And the first step that we have is to actually prepare this. So in this case, you're going to react red phosphorus with iodine, and this is going to give you Pi3. And in the second step, Pi3 will react with the alcohol to give you an alkyl halide and phosphorus acid. Now let's look at a summary of the three main reactions that we've covered up till now. So for chlorination, the reagents that you use are PCl3, PCl5, and SOCl2, which is the main one. And for bromination, you use HBr. And for iodination, you use red phosphorus plus I2, which is going to give you Pi3, which is your main reagent. So this was chlorination, bromination, and iodination of alcohols. The next reaction is the dehydration of alcohols, and you can do this using two ways. So the first one is going to be using Al2O3 as catalyst, and you're also going to heat this mixture. So dehydration gives you an alkene and water. In this case, you had a 2-carbon alcohol, so you're going to get a 2-carbon alkene. The next way you can do this reaction is by using concentrated H2SO4. So the products and the reactants are going to be the same, the conditions are going to differ. So in this case, you're going to use concentrated H2SO4 as I mentioned previously, and you're also going to heat it to 180 degrees Celsius. So these are the two main ways you can use to prepare alkenes by dehydration of alcohols. And these alkenes can be collected over water since they are insoluble. The next reaction is the oxidation of alcohols, and for this the reagent that we use is acidified potassium dichromate. So we classify this into three types. The first one is the oxidation of primary alcohols. So in this case, the alcohol is going to be oxidized in two stages. The first one is going to give you an aldehyde. And if you distill this mixture, what you're going to get is an aldehyde. But if you continue to heat it, especially if you're heating it under reflux, you will end up getting an acid. So in questions, unless they say that the mixture has been distilled off, you will assume that you're getting a carboxylic acid from here. So the second type is going to be oxidation of secondary alcohols. So in this case, you're going to get the corresponding ketone. So this is a 3-carbon alcohol, and it's going to give you a 3-carbon ketone. Now we move on to tertiary alcohols. So tertiary alcohols don't get oxidized, so there's going to be no reaction.